All right, what we're going to do in example number 4 is write this expression simplifying it as much as we can. And in my final answer, I am going to have a theta. So when we're looking at sine of 30 degrees minus theta, this is a difference of signs. The difference of signs says the sine of A minus B equals sine A times cosine B minus cosine A sine B. Well, looking at my expression, I know A is 30 degrees and B is some angle. So let's go ahead and plug in our values. So we are going to do this. Goodness, I was trying to write sine and I did it with a 3 because I was already a step ahead. So the sine of 30 degrees times the cosine of theta minus the cosine of 30 degrees times the sine of theta. Well, when we look at our unit circle, the one line up is 30. So the sine of 30 is 1/2. So 1/2 cosine theta minus the cosine of 30 is radical 3/2 times the sine of theta. So here I am going to have the cosine theta over 2. I'm going to write it like this, minus radical 3 sine theta over 2. You can see we have common denominators. So that is going to give me cosine theta minus, I'm going to write it like this, sine theta times, no, I'm not. I'm going to put the radical 3 in front so we don't actually try to take the sine of it. Radical 3 sine theta all over 2. And I like it like this, but some people want to say 1/2 times cosine theta minus radical 3 sine theta. Either one works. Boom. Now let's try our difference of tangents. So again, we're doing tangent A minus tangent B. So the tangent of A minus tangent B, that's going to be the same as tangent A minus tangent B all over 1 plus tangent A tangent B. And of course, A is theta and B is 3 pi. All right, so we're going to have the tangent of theta minus the tangent of 3 pi all over 1 plus tangent theta times tangent 3 pi. So let's turn 3 pi, that's a radian, into an actual value. 3 pi happens right there. And that is at -1, 0. So tangent is sine over cosine, which would be 0. So every tangent of 3 pi is going to become a 0. And then 1 plus tangent theta times 0. Well, tangent theta minus 0 is tangent theta. Tangent theta times 0 is 0, so that leaves me with a 1. So my answer is just tangent theta. Boom. let's verify our identities using our sum and difference identities. This is going to be a hoot. So we're going to use both our sine and our cosine identities. So if we look at our sine first, we're doing sine of a plus b. So this is going to become sine of a plus b is going to be where we have a and we have b. So this is going to be the sine of pi over 6 times the cosine of theta. I'm working on the left side because that is the more complicated side, plus the cosine of pi over 6 times sine theta. This whole thing, what I've just done, all of this is that expanded out. Now let's add to that. Now we're going to do the next part. Plus cosine pi over 3. So we're adding. So this is going to be the cosine of a, pi over 3, times the cosine of b, theta, minus, because we're adding, the cosine becomes a minus, sine pi over 3 times the sine of theta. So the second part, this is just nuts. That is that expanded out. All right, so everything with a pi can become a value. Pi over 6, the first line, so the sine of pi over 6 is 1/2 times cosine theta, plus the cosine of pi over 6 is radical 3 over 2. That comes from the unit circle, sine theta, plus cosine pi over 3. The cosine of pi over 3 is 1/2 from our unit circle. Sine of pi over 3 is radical 3 over 2. Sine theta. Wow, and I'm trying to get all of this down to just cosine. So I have half a cosine of theta plus, right here, half cosine theta and another half cosine theta. That is 1 cosine theta. Radical 3 over 2 sine theta minus radical 3 over sine theta. That becomes 0. So cosine theta plus 0 is cosine theta. And indeed, that equals cosine theta. I have proved that identity. That was a lot of fun. I like the proving identities. All right, so that's where I'm going to leave off with this video. Just a couple quick examples because number 6 may take a little more time. So I'll see you in the next video.